that we're going to spend a lot of time talking about ratios, proportions, no percentages in this particular unit, but the very next unit, we're going to turn these into percentages. Talks about scale models, scale drawings, things like that we're going to get into here as well. A lot of algebra continuing into this unit here. So that's why I was stressing that we really understand these rules for simplification, solving equations, inequalities, things like that we need to know. All right, so go ahead and make sure your name's on it, and then go ahead and open it up. And as I said, today's going to be just kind of the basics of something called ratios. How many of you said you know what ratio? Anybody say you know what ratios are? Okay. Anybody want to share what you think? I'm not expecting a textbook definition here, but just something general. Jack? So like an equivalent ratio, you can have like equivalent fractions, equivalent ratios, I agree. He mentioned the part thing, and that's good because we're going to talk a lot about that today. Anything else for ratios? You know what ratios do? Like, what's the purpose of a ratio? Isa? Good, to compare. We're comparing quantities. And that's what, you know, with the definition here, a very basic one, just says a comparison of two quantities by division we've compared quantities before in the form of inequalities. We're going to look at it in a little different lens this time. So let's jump right into an example here, a very traditional, stereotypical example. A classroom contains 16 boys and 12 girls. Big class, 28 kids, right? The basics of it. How would you write, or how would you report out to somebody the ratio of boys to girls? We see ratios all over the place and making comparisons. And this is one of those cases, like you're looking at a classroom. I know you know, my students are in school, or my kids are in school, and we're looking at their classroom and the division between the boys and the girls. Like my daughter has a class that's primarily boys. Feel bad for her, all right? It's like, I don't know, if it's like 18 boys and 6 girls or something lopsided like that. So, yeah, I really worry for her, all right? No offense, boys, all right? I'm a card-carrying member too, but it's still, you know, boys are a different breed, all right? But a comparison, when we make the comparison, can be like Jack had mentioned, like a part-to-part comparison, which we'll delve into later, sometimes even like a part-to-whole. So in this first one, boys to girls, how would you, give me the numbers, what would you say for this one? Ben? Yeah, it'd say 16 to 12. And anytime you see a ratio, and this is just general practice, how do I write that? There are a couple ways to do it. Ben, how would you say to do it? Anybody prefer the colon like that? Okay, what's another way if you chose to do it? Any other? Jack? Well, that would be more like a fraction bar, so yeah, you could kind of do that. I would prefer, rather than that, something else. Just very literal. Go ahead, Ben. Now, we could write the word 2, like just T-O, like 16 to 12, like that. But I wouldn't, on this one, I want to actually write it in what we would call simplest form. So we know how to reduce fractions. We know what common factors look like. So if, in a comparison like this, if they share a common factor, we want to reduce it. So we would say the ratio of boys to girls is what, Max? 4 to 3. And I'm going to write this the other way. See how you can use the word 2 in there as well. Unless I tell you otherwise, and I doubt I will ever tell you otherwise, always put ratios in simplest form, just like you would fractions, okay? So you don't have to ask me, like, Mr. Lux, do you want this in simplest form? Yes. All right, always. So what about the ratio of girls to boys? Is it also 4 to 3? Order matters. Emily? We're going to reverse it, absolutely. So we'd say that's a 3 to 4. 12 to 16 would reduce to 3 to 4. So in my example that I use with my daughter's class, 18 girls, or I'm sorry, 18 boys, 6 girls. What is the ratio of boys to girls in that class? Cameron? 18. Bless you. 3 to 1, yep. Ouch. Now, what's that mean? Like, if to someone who maybe doesn't understand ratios, and you say, well, the ratio of boys to girls in this class is 3 to 1. Can you put it in simpler terms? Like, what is that actually implying, Jack? Yeah, so I got 3 boys here. I would pair up 1 girl. I got 3 more boys. I got 1 girl. And every time you do that, that's how it's going to work. Very lopsided. Okay? So now we compare the ratio of boys to students. So this is where I would say, in my classroom, I would say the ratio of boys to students, use these numbers, not my daughter's classroom, but use the numbers up here. How would that change our ratio? Let's go boys to students. Aiden? Which is how many? So now we're working with 28, okay? So you're saying it would be like a 16 to 28, Aiden? Should I reduce that? That was a joke. Please. Frankie? 4 to 7. So if I was talking to somebody about my classroom, I would say, well, 4 out of every 7 students are boys, right? So then what would my ratio of girls to my classroom be? Girls to classroom. 9? Not 6 to 7. Because if I had 6 to 7 girls, 4 to 7 boys, that would be more than the whole amount. And that's what I was kind of leading us into what we're going to do next. Mara? It would be the difference here. Yeah, it would be 3 to 7. So tell me, how do I, if I knew one part like that, how do I find the other part? Like if I'm talking boys and girls, I've got 4 to 7 boys. How do I find the remaining balance? Jack? Yeah, you find the difference because the rest of the class are girls, so then it would be the remaining 3, and it would be a 3 to 7. Okay? These are examples here, the ones we just did, of what we call part-to-whole ratios. Jack referenced it earlier in the class when he talked about a part-to-part. Up above, when we do boys to girls, that's a part-to-part. Now, we know part-to-whole ratios a little differently. When I say part-to-whole, can you think of another word we often use to describe what a part-to-whole ratio is? Brooke? Good, it's a fraction. Yeah, we talk about fractions all the time. Like 1/4 means 1 out of 4. 2/7 is 2 out of 7. That's the whole amount. So if I ever ask you for a part-to-whole, I'm asking you for the fraction. Okay? So like here, basketball player made 12 baskets in 18 attempts. We want a part-to-whole on this. So you have to read it carefully. Are we going to combine these two numbers, or are they in the form that we need it to be right now? What would you say for this one? Kate? Okay? So if you do, what's your common factor here? So if I divide by 6, I get 2 to 3. So you're thinking like 2/3? What do you guys think? 2/3? Yeah, so we could say this person made 2/3 of their attempts, his or her attempts. Sounds right. Why didn't you add these? Why didn't we get 30? Because up above we had 16 boys, 12 girls we added. Why don't we add, Emily? They didn't make 30 attempts, right? The attempts mean, cut off the 1 there, but the attempts mean the whole, right? The total. All right, so how would I do this as a part to part? And you could still do a part to whole with the colon or the word to. All right, that works too. But what would a part to part be? What am I comparing here, part to part? You don't oftentimes hear this in terms of like basketball shots and things like that. What am I comparing, Aiden? To how many times? Yeah, they got it in versus how many times they missed. So like makes to misses. So if we did a make to miss ratio, what would it be? Make to miss. Nadia? 2 to 1, yeah. Tell me how I could take my part to whole ratio and get my part to part ratios. Because another part to, well, before I get to that, what would be the other part to part ratio? This was make to miss. Mara? 1 to 2, you said? Yeah, 1 to 2, miss to make. Okay? So again, my question comes back to this. How could I go from here and get my 2 part to parts? Brooke? Mm-hmm. Very good. Yep. 2 is already one of your parts. You find the difference between those, then get your other part, and then compare them. Great. Okay? So let's try a couple of examples here. You guys can just do this here. So example 1, ratio 10 roses to 6 carnations. Number 2, 15 out of 100 campsites are reserved for campers with pets. So read them carefully. See if you can determine what they're asking. am I missing? Okay. Well, yeah. You know what? I didn't want her to check it, so you felt like you knew what to do on all. That's fine. If you have any questions, but I don't need to see it.